Dilution calculations that you'll get right every time. Start with 100 mils of water. I'm putting in 2 drops of food coloring. What's the concentration of this solution? 100 mils of water plus 2 drops of food coloring. Well, that would be 2 drops per 100 mils. If I multiply numerator and denominator by 10, I can say that's 20 drops per 1,000 mils, or 20 drops per liter. That's my initial concentration, 20 drops per liter. Now we'll perform some dilutions with it. We'll take a 20 ml aliquot. An aliquot is a portion of our 20 drop per liter solution. We'll keep it in beaker 1 as a comparison. I'll take another 20 ml aliquot of our 20 drops per liter solution and put it in beaker number 2. But in beaker 2, I'm also going to put another 20 mils of water. So the volume is increased from 20 mils up to 40 mils. Since the volume increased by a factor of 2, the concentration decreases by a factor of 2. Those volumes, 20 and 40, can be combined to make what's called the dilution factor. You can say the dilution factor is either 20 over 40, which is a half, or you can say it's 40 over 20, which is 2 times. Use that dilution factor to calculate the final concentration. Take your initial concentration, 20 drops per liter, and multiply by 20 over 40, which is a half, gives you 10 drops per liter. Your final concentration is 10 drops per liter. Or if you prefer, take your 20 drops per liter and divide it by the dilution factor of 40 over 20, divided by 2, and you have 10 drops per liter. Don't memorize a formula, just make sense of it. You'll get it right every time. All right, beaker number 3. Again, a 20 ml aliquot of 20 drops per liter solution. This time we're going to add 40 milliliters of water. And so our total volume will be 60 mils. Since the volume increased from 20 mils to 60 mils by a factor of 3, therefore the concentration will decrease by a factor of 3 as well. So 20 over 60 is a dilution factor. It's a third. You multiply it by 20, and the final concentration is 6.7 drops per liter. Or if you prefer, you can get 60 over 20, which is 3 times. Take your initial concentration, 20 drops per liter, and divide it by 3, 6.7 drops per liter. All right, beaker number 4. Another 20 ml aliquot of 20 drops per liter solution. This time we're going to add 60 milliliters of water. 20 plus 60 will give us a total volume of 80. The volume increases from 20 to 80, that's a factor of 4 times, so the concentration will decrease by a factor of 4 times. Take those two volumes, 20 and 80. 20 over 80 is a quarter. Multiply a quarter by the initial concentration of 20 drops per liter. The final concentration is 5 drops per liter. Or if you prefer, dilution factor is 80 over 20, it's 4 times. Your initial concentration is 20 drops per liter, divided by 4 is 5 drops per liter. You'll get it right every time. Don't memorize a formula. Okay, the last one. Take our last 20 ml aliquot, whatever's left there. This time we're going to add 80 milliliters of water. That'll bring our total volume up to 100 mils. So if we increase the volume from 20 to 100, we increase it by a factor of 5 times. Therefore, our concentration decreases by a factor of 5 times. The final concentration will be 20 drops per liter times 20 over 100, or 1/5, so that's 4 drops per liter. Or the final concentration is 20 drops per liter divided by 20 over 100, in other words, divided by 5, and it's 4 drops per liter. You'll get it right every time. Don't waste your time memorizing formulas. Just think logically. You'll get it right, guaranteed. Let's take just a moment to look at dilution calculations on a graph. Here's a plot of concentration versus volume. We started with 20 milliliters with a concentration of 20 drops per liter. We doubled the volume by a factor of 2 from 20 to 40, and that decreased the concentration by a factor of 2 from 20 drops per liter to 10. When we tripled the volume from 20 to 60, that reduced the concentration by a factor of 3 from 20 to 6.7. When we increased the volume by a factor of 4 from 20 mils to 80 mils, then the concentration decreased by a factor of 4 from 20 drops per liter down to 5 drops per liter, and so on. So this is an inverse relationship. As one variable increases, the other decreases proportionately. And this is the very same relationship that describes the pressure-volume relationship of gases, which I have plotted here. This is described by Boyle's law. Notice that as the pressure of a gas increases, its volume decreases proportionately. So in both these examples, you can solve problems involving dilutions or pressure and volume of a gas by making logical statements and making ratios that make sense, rather than memorizing formulas, and I would encourage you to do that.